what does it mean to take the log of a number? Let's first consider what it means to take the square root of a number and then relate the procedures to one another. So let's take the square root of 4. Now we all know that the square root of 4 is equal to 2, but let's consider the procedure involved. So what does it mean to take the square root of 4? It means to find the number when multiplied by itself is equal to 4, right? So this operation is inferring the following procedure. Y times y is equal to 4, right? So we see that if y is equal to 2, 2 times 2 equals 4, that satisfies this equality, and so therefore the square root of 4 is equal to 2, right? And that's it for, that's all there is to taking the square root, right? But we see that the procedure involved is a little bit more interesting than actually just, stating what the number is, because we've been dealing with square roots for so long that we do them sort of just fluidly, right? Square root of 4, 2, square root of 16, 4, square root of 25, 5, square root of 100, 10, right? And so on. And so we don't really think about the procedure involved. So let's take a look at what it means to take the log of a number. So if we take the log, and we'll do the same number, the log of 4, right? Well, what this operation is inferring, it infers the following procedure. It says 10 raised to the what power? 10 raised to what power equals 4, right? So we can write that down in the following way. 10 raised to what power is equal to 4, right? Well, what does y equal? Because whatever y is, that's the answer to this problem. That's what log of 4 is. So y could be equal, let's just try some stuff. Let's let y equal 0. 10 to the 0 is equal to 1. So that's not right. We need it to be equal to 4. We could try 10 to the 1. 10 to the 1 is just 10, so that's too big. It's not 4. And we could try 10 to the 0.5, and then 10 to the 0.5 is 3.16, so that's a little bit too low. Then we try 10 to the 0.6, and that's 3.98, so now we're getting close. And in fact, if we continue this iterative process, we will arrive at y is about equal to 0.602. And so this is equal to the log of 4. And that's all there is to logs, right? Now, one thing to consider real quick, and a quick note, is that whenever we write the log of 4 like this, it's understood that there's a 10 here, right? And that's why there's a 10 here. But if there's a log base, log base 3 or log base 9, then all you do is whatever this base is, you replace this 10 with that base. And then you carry out the operation like we just carried out. Now there's going to be some tricks for taking logs, and we'll learn those in the tutorials to follow, but this is just a basic introduction in what it means to take the log of a number, okay? So just like with the square root where it's become second nature, right? The logarithm will become second nature if you work enough examples, you'll see that it's not too bad, okay? So this is equal to the log of 4. Moving along, we're going to consider the graphs of these functions in the next tutorial. Then after that, we're going to consider some logs with different bases. I'm going to step aside and give you a clear screenshot.